Hello, students. Today we'll understand a program that draws a spinning rainbow sphere on screen. A sphere has two imaginary lines through it. One runs top to bottom, like Earth's pole. We call this the vertical y-axis. The other runs left to right through the middle, the horizontal x-axis. These two lines meet at a right angle, so we say they are perpendicular. Spinning like a clock's hands is called clockwise. The opposite way is anticlockwise. Our program spins the sphere in 4 10-second stages. First clockwise around the y-axis, then anticlockwise around the same y-axis, then clockwise around the perpendicular x-axis, and finally anticlockwise around the x-axis. A label on screen always shows which axis and direction is active. The sphere shows rainbow colors because each tiny patch on its surface is colored by the direction it faces, like a color wheel wrapped around a ball. It looks shiny because the program calculates 3 kinds of light: ambient light reaching every part softly, diffuse light falling directly on facing patches, and specular light, the small bright highlight where light reflects into our eyes. Together these are called Phong shading. The computer builds the sphere from hundreds of tiny flat patches, like panels on a football, and redraws them 60 times every second, so our eyes see one smooth, glowing, spinning sphere. In short, 2 perpendicular axes for stages of clockwise and anticlockwise spinning, rainbow colors, and Phong shading for shine. Keep exploring, keep coding, and keep asking how things work.